You might recall back when we did congruent triangles, we did an activity called Daily Day. And one of the triangles where you could not prove that triangles were congruent was when you had two angles that were congruent to each other. Just because the angles were congruent to each other didn't mean that the sides were congruent to each other. So you couldn't prove triangles were congruent by angle, angle, or angle, angle, angle. But you can prove that triangles are similar, because remember, there are two things that have to happen for triangles to be similar. Their sides have to be proportional, and their angles have to be congruent. So two triangles are similar if they have two pairs of congruent angles. We don't need the third. Yes, the third automatically exists because of the third angle theorem, but we don't have to have that third one. So having two pairs of congruent angles means that the triangles are automatically proportional, okay? We also can prove that triangles are similar by the side-side-side theorem. Now, what it is like with congruency, we said when three sides of one triangle are congruent to three sides of another, then those triangles must be congruent. But with similarity, it's when two triangles are similar when three pairs are proportional. So when you have those proportional sides, we can prove that they are similar. So in this one, we could compare 12 to 6, that's short with short. So 12 over 6 is 2, 14 over 7 is 2, and 20 over 10 is 2. And so they all have the same ratio, and therefore these two are proportional because there are three sides that have similar ratios. Then we also have that side angle side. Again, that angle has to be included in between the two sides. And so we have our two sides and our included angle proportional to our two sides and our included congruent angles. So our sides are proportional, 30 over 10, 18 over 6, that's both 3. They have a ratio of 3, so this has a scale factor of 3 or 1/3. And then the angle is congruent, so side angle side works. So if we look at these and I ask, are they similar? And then name the postulate. So we want to compare. And now you don't have any way to know, there's no markings, so the only thing you can do is compare short with short, medium with medium, and long with long. So we would compare 9 with 6, so 6 over 9. We would compare 10 over 15, and we would compare 12 over 18. Now you may be wondering, why did I do 6 over 9 instead of 9 over 6? No particular reason. It doesn't matter. You can do 6 over 9 or 9 over 6 as long as you use 9 and 6 in the same ratio. Well, 6 over 9 is 2/3, 10 over 15 is 2/3, and 12 over 18 is 2/3. So yes, these are similar by side, then similarity theorem. Okay, this one has two angles. However, this is 68 and 62, this is 68 and 50. Well, I need that third angle to see if they would be the same. Well, 68 plus 50 is 112, and then subtract that from 180, and you would find out this other angle is 62. Well, notice, now we've got 68 and 68, 62 and 62, so we do have two angles congruent. If we have two angles that are congruent, then yes, they are going to be similar by angle similarity. Okay, now this one, here's where you have to be careful. This is a triangle right here. That's a triangle. That piece, not a triangle. So we right now cannot compare. We have to compare triangles to triangles. So we need the yellow triangle, and then we need the orange triangle. So the orange triangle, KM, is 10, and KN is 15. So we're going to need those whole sides, part, this whole. Okay? So what we want to do is compare 8, KL, over 10, KM, and we want to compare that to 12, KP, over KN, which is 15. Whole, right? Whole side over whole side. Well, 8 over 10 reduces to 4/5. 12 over 15 reduces to 4/5. So yes, they are similar. It's hard to not say congruent after saying it so much. Side angle side similarity. They are similar to each other. So let's look at another one. Number 4. It appears that it possibly could be side. Well, we need to check. We need to compare our short with our short, our long with our long, our medium with our medium. So if we do that, short with short would be 5 with 9, it would be 10 with 15, and it would be 8 with 12. I just pulled them all over just to save a little time and space and work. pull them all over onto one triangle, on top or on bottom, it doesn't matter which. But when you check these, 9 over 5 can't be reduced. Well, 12 over 18, or 12 over 8 can, and 15 over 10 can. But since they do not all have the same ratio, the answer is no. They are not similar. They're not proportional. Now, this one's tricky because it doesn't look like we have a lot. But since these two are right angles, that means these two are parallel. Those two sides are parallel to each other. If those two sides are parallel to each other, that tells us that corresponding angles are congruent. We also have, we don't necessarily need it, but it is something that we have. This angle up here belongs to the small triangle, this one, and the big triangle, this one. It's reflexive property. So I have two angles of one triangle that are congruent to two angles of another triangle. That means that these triangles are similar by AA. Now this one potentially might be side angle side because I have angles and sides, but I need to compare them. Well, this is 70 and 30, which means this side, that angle is 80. This is sum of the interior angles is 80. That's 110, which means that one is 70. So our angles are congruent. Now we need to check and see if our sides are proportional. So I'm going to match short with short, 8 over 12, and long with long, 10 over 15. 8 over 12 and 10 over 15 both reduce to 2/3, which means yes, these are similar by the side angle side theorem of similarity. Okay, now why do we need this? Well, because sometimes when we have missing information, we need to know how to set up triangles so that we can find the missing pieces. But we don't have a similarity statement that tells us how it matches up. So we have to figure out, like I don't know, like I can probably figure that 10 goes with 6, but I'm not sure if 15 goes with y or if 15 goes with x. So here's what you want to do. You want to look at it and you want to see, what do I know? Well, if I have parallel lines, that means I have angles. I know that if lines are parallel, alternate interior angles are congruent. And same thing, if lines are parallel, those alternate interior angles are congruent. And I don't need it, but I do know, and you might have seen this first, vertical angles are always congruent. Now I have it marked up. Those two triangles are similar by angle, angle. Since they are similar, I can use scale factors or I can use proportions to set it up and solve and figure out what those missing sides are. Now, so I like to pull everything over to one triangle. It doesn't matter which one. So 15. Now notice how 15 is marked. 15 is marked between the 1 angle B and the 3 angle C. And EC is the same. So 15 matches up with Y. So I'm going to put the Y on top of the 15. Okay, the 20. 20 is between 2 and 3. X is between 2 and 3, so 20 goes with X. And then that leaves 10 to go with 6. Oh, I messed up. Let me fix it. Sorry if I confused you. I put the Y on top. I should have put the X on top. That's what you got to be careful of. Don't make that mistake. Okay, you got to make sure that you keep everything in the same location. It doesn't matter where it goes. Whether it goes on top or on bottom. I could do 15 over y or y over 15. But once I established y over 15, I needed to do everything the same way. Anything over here goes on top of everything over here once I set that up. Now I set up my proportions. I want to know what x is. So to find x, I would do x over 20 equals, well now I only have these three, right? Because I know it's y over 15 equals x over 20 equals 6 over 10. Those are my three proportions. Okay, so I set that up. Well, I want to know what x is, so I'm going to cover up because I have to know if I use that, right, x and y, that's too many variables. I don't want to do that. So I cover it up. X over 20 equals 6 over 10. Using the cross multiplication property, 120 divided by 10, and you get that x is 12. Y, so now I don't want to use this x. I could plug in, I could substitute in 12 for x, but I don't want to do that. I don't like to use what I know, what I found, if I don't have to. I already know the rest of it, so I can do y over 15 is equal to 6 over 10. Okay, and so I can cross multiply. 15 times 6 is 90, divided by 10 is 9. Now again, if you're a scale factor person, here's your scale factor right here, 6 over 10. Okay, my scale factor is either 6 over 10 or 10 over 6, depending on whether I'm getting bigger or smaller. I'm getting smaller, x is smaller, so I would take, you still have to know 20 goes with x. I would multiply 20 times 6 over 10, or the reduced fraction of that, and that would still give me 12. Okay, and then I would multiply 15 by 6 over 10, and that would still give me 9. So using scale factors or proportions, both of them work. Now, you have to be careful. These look similar, but number 8 doesn't have parallel lines, so this is going to be a little bit different. I gave you that angle R is congruent to angle T. Well, we look, what else do we know? Because we've got to have some way to know how these pieces all match up. Those are vertical angles. RSQ is congruent to TSU because vertical angles are always congruent. Now I can see how everything matches up. So again, doesn't matter. Now notice this time, see I'm going, I have X, which is on this triangle, and I have Y, which is on this triangle. So this is why I like proportions, because I don't have to worry about the scale factor. So I'm going to pull all of my numbers over to one of the triangles. Doesn't matter which one. I'm going to go ahead and mark all my lines this time so I remember where I'm putting everything. And I'm going to pull everything from the right triangle over to the left triangle. Again, it doesn't matter where you go, as long as you're consistent. So X, RQ. Look how RQ is labeled. It has one mark on R, no marks on Q. So I want the exact same piece over here. One mark on T, no marks on U. That means that X corresponds to 24. 21. 21 is RS. RS has one mark and two marks. So I'm going to go over here, find one mark and two marks. So 18 is marked exactly the same as 21. So I'm going to put the 18 underneath the 21. Now notice, this time here they crisscrossed. Here it was top and top and bottom with bottom. So you have to use the angles to see how things match up. Okay, you've got to mark them. You've got to see how they match up so that you can tell how to set up your proportions. Okay, so we have x over 24. I want x, so x over 24 equals 12 over y doesn't do me any good, so that means it's going to set equal to 21 over 18. Well, I can do 21 times 24, divide that by 18, and I get that x is 28. Okay, now I want y. So I do 12 over y. I'm going to start with that one. I don't want to use the x that I just found, so I'm going to stay with the 21 over 18. It always will be that way. Okay, multiply 12 times 18, divide by 21, and you get that y is 9. So y should have gotten smaller, right? So that would be multiplying 12 by 18 over 21 if you're a scale factor person. And then x got bigger, so that would be 24 times 21 over 18 if you're a scale factor person, okay? So again, scale factors still work. I'm just not using them. I like to use proportions. So pick a method, and you can use whatever you like. All right, number 9, we've got these overlapping triangles. Highly recommend that you redraw these as two separate triangles so that you can see what goes together. So if we do ADE right here, ADE, AD is X, AE is 6, and DE is Y. And then we have AB, which remember part plus part. So this side is X plus 18. This side is 6 plus 24. I know it's not drawn to scale, it's okay. And then Y and 35. The bottom of it is 35. Okay, we know the whole bottom. We had to find the whole sides. But now you have everything you need to set up your proportion. Okay, it doesn't matter which way you pull it over. Okay, over X, over 6, over Y. Here's Y. These are corresponding angles. These are corresponding angles, and this angle is reflexive. And so we have that these are similar by angle, angle, which angle is our most useful. It's the one that we use the most because usually what we're trying to find is a side, and so we can't use side and side or side, side, side. Okay. So this one is the most useful, although we will use some version of side and side here. Or actually we'll use angle. So we set it up, x, so we just write down what we wrote. X plus 18 over x equals 35 over y doesn't help, so we're going to use 30 over 6. Now, if you notice, look, 30 over 6, that reduces to 5, right? So here's one thing you could do. Use your algebra skills, make that 5. So now you have 5x is equal to x plus 18. When you do your algebra, you get that x is 4.5. Or you can cross multiply. Just don't forget to distribute that 6 times x and 6 times 18. And then 35 over y is equal to 30 over 6. Again, that's 5. So 5y is equal to 35. And it's 7. Again, you can cross multiply. 35 times 6, 30 times y, and you can do the math. And you would get that that y is 7. Okay? Sorry, I noticed something was wrong with my key. Okay, a surveyor, number 10, a surveyor wants to determine the distance across the lake. Well, it's hard to just go over there and measure it, right, with a ruler. So why can he use similar triangles to solve this problem? Okay, here's what we know. We know that those two angles are 75 degrees. Okay, we also know, without knowing what the actual measurements are, we know that those two are equal to each other. Vertical angles are always equal to each other. And so we know, because we have two angles of this triangle, congruent to two angles of this triangle, that these are similar triangles by the AA similarity theorem. So what is the distance across? Now again, we need to figure out how to match things up. So to match things up, we use our markings, okay? So the 132 and the D, notice that that has 1 mark and no marks. That has 1 mark and no marks. So it would be D over 132. I'm going to pull everything over here. It's a bigger triangle. I have more room to write. Notice that I put it on bottom, so I'm going to pull everything on bottom. That means the 178 goes underneath the 445. Okay, now 445 and 178, that would give you your scale factor if you want to use a scale factor. Or you can set up your proportion. Now D over 132 is equal to 445 over 178. Using the cross multiplication property, you would get that D is 80 meters. That doesn't seem right, does it? So 132 times 445 divided by 178. Ooh, that's not right at all, is it? 330 meters. Okay, I had it wrong on my key again. But you know what? Here's a good example, a good thing that I can show you from that mistake. I make mistakes too, so just be careful. Okay. The reason that I knew that was a problem is because the original answer I got meant that D was shorter than the 132. Well, that didn't make any sense. This is a bigger triangle because 445 is bigger than 178. So I knew that I had made a mistake and needed to go back. So don't forget, in real-world situations, in every situation, you need to make sure that your answers make sense, that they're realistic, okay? So that's just a good thing to see, okay? Now, let's look here. At a certain time of day, a 1.8 meter tall person standing next to the Washington Monument, here's your person, okay, casts a 0.7 meter shadow. At the same time, the Washington Monument casts a 65.8 meter shadow. How tall is the Washington Monument? So this is what I want to know. I want to know how tall is the Washington Monument. Now we've got the person down here. They're 1.8 meters tall. And they cast a 0.7 meter shadow. Now y'all, this is very, very important. Shadows are on the ground. Okay, I'm not talking about the shade. I am talking about the actual physical shadow that is on the ground. And the ground is horizontal. It's not this diagonal. Shadows are never on the diagonal. Okay, they're always on the ground, on the horizontal. Okay, then it says the Washington Monument casts a 65.8 meter shadow. Now, the guy is standing in the shadow of the Washington Monument. So this entire piece is the 65.8. Okay, so we have that overlapping. Now, you could draw this as two separate triangles too. there are other triangles that are going to come up. Now, the reason that we know that they are similar to each other is because we know that that's a right angle. We know that they both share that angle. It sets up AA, which enables us to use the angle-angle theorem to set up the proportions. So I know that the monument's height divided by the monument's shadow is equal to the man's height divided by the man's shadow. Cross multiplication, or you can use the 1.8 and the 0.7 to get that scale factor, right? Then the monument should definitely be taller than 1.8, so you can use that scale factor, 1.8 if you want. 1.8 divided by 0.7 is 2.57. So we know that it is going to be taller, okay? So we do 65.8 times 1.8 divided by 0.7, use cross multiplication, and you get that the height of the Washington Monument is 169.2 meters. Okay? So the purpose of being able to prove that triangles or any other figure is similar is that it helps us to know how to match the sides up that are going to be proportional for us. So we mark the things that we know, and then we decide, are they similar? Which, if I'm asking you to find the sides, they will always be similar. But you have to know how to match them up. So you use the markings for your angles, because they're congruent, to match up your pieces and figure out what your scale factor